Good day, grade 9 students. So we are already on the fourth quarter of our lesson for Mathematics 9. So we're going to start with quarter 4, week 1, and we're going to discuss about the 6 trigonometric ratios. So to start off, we have the definition of trigonometry. So when you say trigonometry, it has an etymology coming from trigonon, which means triangle, and metron, which means measurement. So literally, when you say trigonometry, it involves measurement of triangles. So defining trigonometry, we have this is the branch of mathematics, just like geometry, algebra, that's concerned with the properties of trigonometric functions and their applications to the determination of the sides and angles of triangles. So this will be the first time that you're going to see some of the terms here in trigonometry, and you're going to see it again, I think, when you already have or when you reach your 11th grade. So start off with our trigonometric ratios. So to be able to define these trigonometric ratios, let's have first the parts of your right triangle. So we are going to solve different kinds of triangles here in trigonometry. It's either a right triangle or an oblique triangle. So on this first part of our lessons, we will be having the right triangles. So let's have first the different parts of our right triangle. So we have here your hypotenuse, which is the longest side of your right triangle. So it's always the longest side of your right triangle. Then we have your reference angle. Is it always that the reference angle is on this part? Okay. We can also have a reference angle dito po sa part na to. We can also have a reference angle dito sa baba. So for this case, so since the reference angle is here, okay, so we have two other parts of the triangle, which is your opposite and adjacent. So the opposite side is the side opposite your reference angle. So yun yung katapat ng ating reference angle. And then your adjacent side is yung katabi. Okay, the one or the side besides the reference angle. So this is your opposite side, this part. And this is your adjacent side. Okay? And your longest side is always the hypotenuse. So let's say, for example, we're going to change the reference angle. Let's put the reference angle here. So this is still your hypotenuse. And then this is already your opposite. And this side becomes now your adjacent side. So it depends where your reference angle is. So again, your opposite side is the one opposite or the side opposite your angle theta, and the adjacent side is the one beside your angle theta. Your hypotenuse is always the longest side of your right triangle. So we have seen here the examples on your learner's pocket, different triangles with different measurement of sides, but with only one measurement of angle, which is 59 degrees. So we are given here with different opposite sides, different adjacent side, and a different hypotenuse. So we have here your triangle COL, triangle LAU, and your triangle DZN. So, putting the measurement of the opposite side, your adjacent side, and your hypotenuse. So, again, your opposite side is always the opposite your angle theta, opposite your angle theta, opposite your given angle. Your adjacent is the one beside your given angle, beside. Then, your hypotenuse is always the longest side. Now, if we're going to get the ratio of these sides, we will be having the ratio of your opposite over the hypotenuse, the ratio of your adjacent over the hypotenuse, and the ratio of your opposite over the adjacent. And upon dividing all these ratios, we were able to see that the ratios of these three triangles are just equal. So this means that the angles, okay, they have congruent angles, okay, and the sides are proportional. So they are similar triangles. And these ratios, they have a specific name. So the ratio of opposite over the hypotenuse, the ratio of adjacent over the hypotenuse, and the ratio of opposite over the adjacent. They are the what we call as our 6 trigonometric ratios. So we have here your sine, cosine, tangent, cosecant, secant, and cotangent. So they have an abbreviation so that you can easily write these ratios. And these are the formula that we were able to see on the similar triangles a while ago. So to get your sine theta, we're going to get the ratio of the opposite over the hypotenuse side. And then to get your cosine theta, we're going to get the ratio of the adjacent over the hypotenuse. Tangent is the ratio of opposite over the adjacent. Cosecant is the ratio of hypotenuse over the opposite. Second is the ratio of hypotenuse over the adjacent. And our cotangent is the ratio of adjacent over the opposite. So that you can easily understand or you can easily memorize these formulas, we have first these three. You can use the abbreviation or our mnemonics SO, KA, TOA. So what's this? So our so that will be sine is equal to opposite over the hypotenuse. So sine is equal to opposite over the hypotenuse. So that's we have a red mark over there. Then for cosine, we have adjacent over hypotenuse. Tangent is opposite over the adjacent. Then to memorize these other three, they're just the reciprocal of our first three ratios. So cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. And we also have a mnemonics for that. We have the cho, sha, cow. So cho, it's cosecant is hypotenuse over opposite. Second is hypotenuse over adjacent. Cotangent is adjacent over the opposite. Okay, so to identify again which is the opposite, adjacent, and the hypotenuse, we have to know the location first of your angle theta or your reference angle. So let's take this one as an example. So we have here your triangle ABC. Okay, here is our angle theta. Then we have to identify first the parts, which is the opposite, the adjacent, and the hypotenuse on this triangle. So since this is our angle theta, okay, it's obvious that our longest side is C, or which is our hypotenuse. Then we have the opposite side. The side opposite angle B is side B. And the side besides our angle B is our side A. So we're complete. We have the opposite, which is side B, our adjacent, which is side A, and our hypotenuse, which is side C. So we can now get the 6 trigonometric ratios. So I'm just going to show the formula for you to write. So we have here your sine theta is opposite over the hypotenuse. So we're just going to look on these three and this formula. So the sine theta is opposite over hypotenuse. Our opposite is B and our hypotenuse is C. Then cosine theta is adjacent over hypotenuse. Adjacent is A and hypotenuse is C. For tangent, we have opposite over adjacent. Opposite is B. And your adjacent is A. For cosecant theta, it's hypotenuse over opposite. Our hypotenuse is C and our opposite is B. Then for secant theta, we have hypotenuse over adjacent. Our hypotenuse is C and our adjacent is A. And finally, the cotangent theta. We have here the adjacent over opposite. The adjacent is A and the opposite is B. And that is the 6 trigonometric ratios of our triangle ABC, in which the reference angle is angle B. So let's try the next example. We have here again triangle ABC, but we have here a specific values or numbers. So we have already here your reference angle. We have your sides 5, 12, and 13. Let's identify first on this the opposite, the adjacent, and the hypotenuse. Since this is our angle theta, okay, so we can see that this is already our hypotenuse, which is 13. And then the opposite, katapat po niya, which is 5. And the adjacent, besides your angle theta, we have your 12. So you have to identify first the opposite, the adjacent, and the hypotenuse on your given triangle. So we can now get your 6 trigonometric ratios. So our sine theta again is opposite over hypotenuse. So that's 5 over 13. We have cosine is adjacent over hypotenuse, which is 12 over 13. And we have tangent, opposite over adjacent. So we have 5 over 12. Cosecant is hypotenuse over opposite. So 13 over 5. And then we have second, which is hypotenuse over adjacent. So 13 over 12. And finally, our cotangent is adjacent over the opposite, which is 12 over 5. Okay, so that is the 6 trigonometric ratios of our given triangle. So for example, we're just asked, for example, what is secant theta? So for this one, so you're just going to get the formula for secant, which is hypotenuse over adjacent. So hypotenuse here is 13 and the adjacent is 12. So our secant theta is 13 over 12. Okay? It doesn't mean that you are always going to get all the 6 trigonometric ratios. So let's have another one. So we have your given angle, angle 30. So this means that it is your reference angle. So kung nakalagay na angle natin, so this is your right angle. So your 30 is your reference angle. So still, we have to get the value of your opposite, adjacent, and hypotenuse. So in this given triangle, our hypotenuse is 2. And we have here the opposite side is 1. And we have here your adjacent side, which is the square root of 3. So since you already have the opposite, the adjacent, and the hypotenuse, we can already have the 6 trigonometric ratios. So we have the sine is opposite over hypotenuse. So we have 1 over 2. We have cosine is adjacent over hypotenuse. So that's square root of 3 over 2. Then we have the tangent is opposite over adjacent. Opposite is 1, adjacent is square root of 3. But based on our rules on our radicals, so okay, we have to rationalize this. You cannot have radicals on your denominator. So multiply by square root of 3 over the square root of 3. So the answer is square root of 3 all over 3. Then cosecant theta. You have hypotenuse 2 over opposite 1. So 2 over 1. So we can have the lowest term, which is 2. Or simpler term. Then we have secant. Hypotenuse over adjacent, so 2 over the square root of 3. Again, we have a radical. So multiply again by square root of 3 over the square root of 3. So that becomes 2 square root of 3 all over 3. And then we have cotangent, adjacent, which is square root of 3, and over the opposite, which is 1. Simpler term, that is square root of 3. So that's how we're going to find the 6 trigonometric ratios. Then we have the example. So let's try to answer your engagement, assessment, or assimilation part. Let's start with the engagement on learning task 1. So we already have an example of this a while ago. So before you can answer that, so you have to remember that you have to get your opposite, adjacent, and hypotenuse. So I will be giving already this opposite, adjacent, and hypotenuse. So you have to know first where is your angle theta. So on this is your angle theta. So we have here your opposite, which is T. We have your adjacent, which is M, and the hypotenuse, which is A. If you already have your opposite, adjacent, and the hypotenuse, you can already have your 6 trigonometric ratios using this formula. So use again this formula to answer the questions below. So we already have your opposite, adjacent, and hypotenuse. It's up to you now to simply put it or put this formulas. Let's have the next. Okay, so in this case, we already have numbers involved. Your triangle KMI or KIM, where your angle or your right angle is an angle I, and your reference angle is on angle K. So, I'll just help you to find your opposite, adjacent, and hypotenuse. So, I hope just go back to the video to find the formula. So, in here, the opposite is 6. The adjacent is 8. And the hypotenuse is 10. So you just have to find the formula for sine, cosine, tangent, cosecant, secant, and cotangent. For example, I'm just going to answer your sine. Remember, our formula for sine theta is your opposite over hypotenuse. Our opposite is 6 and our hypotenuse is 10. So that is 6 over 10. You can get its lowest term, which is 3 over 5. Okay, then just go back again to find the formulas for cosine, tangent, cosecant, secant, and cotangent and get its lowest term. Let's go now to our assimilation part. So on this assimilation part, okay, so I'm just going to find or give you the side. So if this is side R, this is our side A, and this is our side M. So just go back to our formula. What is your opposite, adjacent, and hypotenuse? So it's already given to find your sine, cosine, and tangent. Actually, you just have to get the reciprocal. Cosecant is just the reciprocal of sine. Secant is just the reciprocal of cosine. And cotangent is just the reciprocal of tangent. But let's just give you the parts. For this is your reference angle, your opposite is M, your adjacent is R, and your hypotenuse is A. So that's why your sine theta is opposite over hypotenuse. Our opposite is M and our hypotenuse is A. So that's why it's M over A. So it's just for you to answer the rest or the 3 remaining questions. Last part is our assessment. So just the same questions, just written in a multiple choice. Let's answer, for example, number 1. So for you to answer this, we have to identify first the parts. So since they are using segments, so you just use segments to identify our opposite, our adjacent, and our hypotenuse part. So in this case, this is our reference angle. The opposite side is your side AJ. Our adjacent side is our side CA. And our hypotenuse side is our side CJ. Okay, since you already have this, you can answer already the question. For example, which of the following illustrates sine 52? 52 degrees is our reference angle. Sine, what's the formula for our sine? So, for sine 52, again, it's always opposite over the hypotenuse. Our opposite is AJ, and our hypotenuse is CJ. So it's AJ over CJ, so that's letter B. Okay, so just have to remember these parts for you to answer the remaining questions. So that's 2, 3, 4, and 5. So just, sige, isama natin yung number 2 para yung 3, 4, 5 na lang yung answer nyo. So for example, number 2, we have which of the following trigonometric ratios illustrates AJ over CA? Let's identify what is this AJ, what is this CA. Our AJ is the opposite. Our CA is the adjacent. If we're going to take a look at the formula that we have a while ago, opposite over adjacent is the formula for our tangent. So that is letter C. So, okay, so you just have to find what is secant 52, which of the following, what is this CA, what is this CJ. Then given the measurement already of AJ and CA, you're going to find the ratio of tangent. What is the formula for tangent? This is already the formula. And then just have to identify what is this AJ, what is this CA. Is this the opposite? Is this the adjacent? Okay, that's how you're going to answer your engagement, assimilation, and assessment part. So I hope you understand the first part of our lesson for the fourth quarter and how you're going to answer all the questions for the engagement, assimilation, and assessment part. And I hope we are going to see you again on our next video next week. So that's all for today. Goodbye and good day. Thank you and God bless.